Hi again, and this webinar will be about XOR key extraction. You were very interested in this topic. However, in my opinion, nowadays our database is quite big and there are a lot of XOR keys there. You still wanted to learn how to do it by yourself. So you wanted, we give it to you. XOR key extraction. Several words about XOR, about scrambling. Scrambling is used for most of modern NAND devices. It's used to remove patterns from data, and because random data with without patterns will be stored much better than data with patterns. Data with high entropy will be stored much better than data with a low entropy. Detailed video explanation about what is XOR you can see with this link. Then when we do data recovery process, one of the steps would be to extract the XOR. Yeah, so since our controllers used that XOR transformation, then when we do data recovery, data is scrambled, and one of the steps in data recovery process would be to descramble data. So we need somewhere in this middle of the data recovery process to apply XOR one more time. And after this, we will get original user data. So the scrambling process is the process when we do apply exactly the same XOR key, which controller created, which controller used to data. And after this transformation, we'll get original data without it, not scrambled data. Video with a more detailed explanation about this process you can see by this link here. When we perform this descrambling process, there is only one thing we need to care about. We need to select a good XOR key, compatible XOR key, if we're talking about using XOR key from a database. And how can we do that? How do we select the key? We just, software gives us list of probably good XOR keys for our case, and probably good blocks for testing those keys. So that's the window where we perform this testing. And from the right side, we have XOR key candidates. From the left side, we have blocks where we can perform this testing. And in the center, we have a result of selected XOR key applied to the selected blocks. If we will try to apply XOR key on some random block, I think that it's we can't decide with 100% probability if this is good key or if this is not good key, because like random data, we don't know what should we expect, right? The main problem that if we apply some XOR key to some random block, we don't know what do we want to see actually, right? But if we will apply XOR key to some blocks with some predictable data blocks, for example, where we want to see blocks with zeros, then we understand that if we see zeros, then this is good XOR key. If we don't see zeros, this is not compatible XOR key. Just like this. So here in the left list of blocks, we try to find the block with zeros. This is how do we select XOR key from database. Those zero blocks are really helpful. They do really help to us to select good XOR key. However, those blocks could be used not only for XOR key testing, but we can also use them for XOR key extraction. And that's what we're gonna talk about now. First of all, let's see where did those blocks come from. If we'll have a look on general structure of FAT32 file system, we'll see that it starts from MBR, then we have some reserved space, which is usually filled by zeros. So file system writes zeros here. And then there is a boot sector, then again reserved sectors where there are zeros again, then FAT tables, and so on and so on. So file system writes quite big number of zeros in the start, and in a bitmap it looks like this. This is start of file system. We have quite a big space. White color means zeros in a bitmap. So we can see those zeros here, then we can see FAT table, and our task normally is to find this place, which could be located anywhere in physical image, and then try to apply a XOR key on this block. And if we will see those zeros, that's good. XOR key is correct. If we won't see that, then something is bad. Maybe it's not a good XOR key and we need to try another one. And as I told you, those blocks also could be used not only for XOR key testing, but for XOR key extraction. Why? Because if a XOR key applied to zeros, as a result, we will get actually pure XOR key. You can see this from a XOR key truth table. For example, here you have data. In this column, here you have XOR key. And this is a result of XOR operation between this and this bit. So let's say that we have 0 as a data and 0 in XOR key. Result will be 0, so the same like XOR key. Then if we have 0 in data and 1 in XOR key, result is the 1. So the same as in XOR key. So you can see that the result of XOR key plus zeros is really not changed. I mean, it will be a XOR key after the transformation. So in fact, those zeros from file system in a physical image look like a XOR key. They are XOR key itself in their physical image. And we can try to find these blocks, same like we did for XOR key testing, but instead of testing XOR key on those blocks, we will extract them and then perform some transformation to them and use it as XOR key. That's the approach. That's the way to go. How do we do that? First of all, as I told you, we need to use XOR analyzer, so we should run it, click on this button, then on this button, start auto detection. And what will happen in that moment? XOR analyzer will try to find blocks with zeros or blocks with XOR keys. It will try to search them by next method. The approach is to compare all blocks within physical DOM. And our idea that blocks with XOR keys will have same content. They will have same data inside. Blocks without XOR key will have different data. Of course, sometimes it doesn't work like this. Sometimes we can see by some coincidence similar data without XOR key. But in many cases, this approach works. I would say in most of cases, this approach works. And if we will find several blocks with the same data, there is quite a big chance that those blocks will have the XOR key inside. And how do we compare blocks? How do we understand if blocks have the same data or not? We just take 3 random points, 3 random bytes in each block, read them, and then compare. And if we'll see that these 3 random bytes are the same, then there is a quite big chance that another bytes will be also the same. Of course, all these are things we need to recheck later. So we got those test points, we read them, and then as a result we got such a table where each line represents result from each block. So one line is one block, and here we have address, physical address of the block, value, it's values from those test points, and signature, it's a first 3 bytes from these blocks. And it's quite important thing, we'll see this later. So signature, it's the first 3, sometimes 4 maybe, bytes. Again, there is a picture here with a XOR analyzer, but now let's have a look on this from XOR key extraction point of view. So far we shouldn't care that much about, for example, this part of the block of the XOR analyzer, about this part. And now I will explain you more detail this. So as before, in this area we have list of blocks where we probably can find blocks with XOR key. And then in this area we can see pattern of the selected block. So in a previous case, when we did select XOR key from a database, we switched this area to the result tab. So we could see result of XOR key applied to the selected block. Now we switched this tab to the source, and source is the block. So we see data from selected block. And then in this area we have a tools to run auto detection. So this, if we will click on this button, utility will start some script which will compare blocks. So we'll arrange them in special order here and bring some keys, key candidates into this area. So it's a more or less automatic tool here. Read values option will just read those bytes, these ones from each block, and shows you them here, and blocks of course. And sort blocks, with this option you can sort blocks with a different manners. You can sort them by value, by signature, by address. Several options are there. The next thing we should talk about, it's our block parameters. So here we can adjust block size and test indexes. It's our indexes which from which we will have those values. And we can set up them manually, or when we click to run auto detection, utility takes them automatically. By default, we have here 3 indexes. If you want to do more precise analysis, if you want to search for more similar blocks, then you can set up more indexes here. For example, 5, 10, whatever, and then the chance that you will find blocks with exactly the same data will be higher. Default value is 3. Usually it's enough. And then the block size. Block size in this field is is equal to the block size which we have now in the configuration. So if in configuration we have physical block size, which VNR took from memory chip configuration. Then there will be a physical block size in this area. If you already if you have set up already logical block size, then there will be a logical block size. So from the beginning, VNR takes this block size from the structure. Like you can see current block size usually in these areas, or if you will open structure of the dump, you will see block size there. So by default, it's that block size. And with these buttons, you can adjust it. You can adjust it. You can make it 2 times smaller, 4 times smaller, or you can divide it by 3, by 6. I'll show you later when do we want to divide it. I'll answer on all questions from chat a little bit later. So that's the XOR analyzer interface. And then when we clicked to this auto detection button, we'll get some result. And what we want to do, what we need to do in this moment, we need to just check what kind of data we have in those blocks on the top, because VNR will bring to the top automatically blocks that have a XOR key inside with the biggest probability, with the highest probability. And yeah, so our task is to check several blocks from the top. And if everything will be good, we'll see XOR key pattern. By this link here, you can see how different XOR key patterns may look like. And if you see something like this, then you may understand that this is a XOR key. This is not a data block, but a XOR key. And once you found it, that's good. The next step would be to understand how many XOR keys you may have in this one block. Because the thing is that one block may have several XOR keys inside. Usually it's 2 keys or 6 keys, 4 keys. And how can you see that? You should just have a look, and you should just have a look on patterns. And check how many repeatable patterns can you recognize here. For example, do you see this line in this area? It's 1, 2, 3, 4, 5, 6. So that means that we found that we have 6 keys inside this one block. It's repeated 6 times. And once we found this, then we can come back to this area, to block parameters, and divide block size for analyzing by 6. Why would we want to do this? Because if we will have such result, so we can extract full this block. Well, actually, we can extract only this small area later, but it's gonna be more complex, more complicated. It's much better now to divide test block for analysis here by 6. So utility will try to search will try to compare not such big blocks, but smaller blocks with the size 1 divided by 6, like these ones. And then instead of 1 block here with this XOR key, you'll get 6 blocks. And it's much better because you, instead of only 1 block, you will have a choice 6 times more, right? You can select, you will, later you will see that you need at least 3 blocks for XOR key creation. And 1 block is not enough usually. So if you have just 1 block with many keys inside, it's much better to divide it by the numbers of keys, divide block size for testing by the numbers of keys that you can see in 1 block, and then run auto detection again. As a result, you'll get such a small key here. Yeah, so you see that we have 6 keys. Then we divided block size for testing by 6 from the previous one, and click to run auto detection again. So now instead of the big blocks, VNR will analyze smaller blocks, will compare smaller blocks. It will show you 6 times more blocks in this list, and 6 times more XOR keys will be found. After this step, all we need to do, we need to select 3 blocks here by this with these checkboxes, and and click to extract selected blocks. Why do we need 3 blocks? Because if we will use only 1 block, it may have some bit errors, some contaminations, and those bit errors can damage full dump. If we will use at least 3 blocks where we suspect to see same data, where we're supposed to see same data, then we will compare all those 3 blocks bit by bit, and one result will be created out of these 3 with a like say most probable variant of bit. Well, you will see that on the next step, what we're going to do with these blocks. Yeah, that's what I was talking exactly. So after we clicked on extract selected blocks, we'll get 3 offset elements where we'll have those keys. With ECC element, same like this one, we can control using ECC map if we don't have any bit errors. And with bit verify, we will compare each bit from each offset. And then if some of offset will have some contaminations, because we can't be completely sure that there are only zeros in those blocks, right? One block may have some small portion of data which we just couldn't recognize visually. We didn't see that. So if we will see that block, that small portion of data will damage full dump. But if we will use 3 offsets, then probability will be much smaller. You can use 5 offsets if you want. You can use 7 offsets. You just don't use 2 or 4 or 6, because in this case there could be ambiguity. You can see for example, 2 offsets may have 1s at some point, and 2 offsets may have 0s at some point. And VNR will not be able to take a decision which 0 or 1 to use from that case. So that's why we use only odd values for inputs for bit verify. The next topic, what kind of XOR keys we may have. There are different XOR key types, and one of the most popular that we usually see, it's when only a data area is XORed. So this is typical page structure of, for example, some Phison and Toshiba controller. And usually, in many cases, only data area is XORed. So here we have XOR, here and here and here, and service area and ECC are not scrambled. They are like untouched, original. In other cases, data area and service area could be XORed, and ECC is not. And in most, let's say, complicated cases for extraction, full page is XORed, like everything. It all depends on which stage controller does use XOR transformation. If controller use XOR transformation at the very beginning of of the way of where data is going to the memory, then only data area would be XORed, because controller first will apply XOR transformation, then it will create service area for the data, and then ECC will be calculated, and so on. If controller apply XOR a little bit later, when there is service area already, then service area and data area will be XORed. And if XOR is applied on the very last stage, when controller has already ECC and XOR and, and data area and everything, then full page will be XORed. And because of this, because of such different types of XOR keys, sometimes we need to use this option. We shouldn't forget about that, about this button, adjust key to page layout. Well, actually, no, I forgot to tell you about data area. So have a look. We had a ECC element, then we got 3 blocks with a probably, well, with XOR key, let's say, already here. So we have here 1 copy of XOR key, second one, and third one. With ECC elements, we can check if they don't have bit errors in the ECC map. And then with bit verify, we eliminate probable data contaminations. And then we will need to remove from this XOR key ECC areas and service areas, because you should understand that on this stage we still have ECC, so we extracted full blocks here, and we still have ECC for these blocks, service area, and so on. And if we will apply such a key to our dump, so then service area will be totally corrupted, because if we apply this service area to all another service area, so it will be changed. And then later, we will not be able to analyze it on a marker stable stage. So to prevent this, we'll use this element data area, which will remove from these blocks everything but data area. So after this data area element, we'll not have ECC and service areas. We'll have only data areas. For example, if at the beginning we had a page like 92, 16 bytes, so here we'll have 8192. So 8 times 1024 bytes. Well, of course, now I'm talking about the case when data area only XORed. So when we get such a key, the next stage would be to click on this button to adjust key to the page layout. Why? Because we have only data area XORed, like this case we have. Now service area and ECC is XORed. So it looks like this. XORed service areas, XORed data area, then service area ECC, and the page is like bigger, let's say. XOR key for data area only has this size, like for example 4096 or 8192 bytes. So it has data for data areas only. And if we will apply such a key to the page without any adjustment, just directly, So then first data area will be XORed, then this part of XOR key will be applied on the service area and TCC, and everything will be corrupted from this point and to the end of the page. So we don't want to do that. What do we want to do? We want to click on this button, adjust key to page layout. And if we want to do this for data area only, so we shouldn't even uncheck this outer option. Outer option could be, outer setting could be checked. In this case, XOR key will be adjusted to data area only, like we can see here. What does it mean? It means that VNR will insert zeros between these data areas, let's say. So then after this XOR key area will be applied to first data area, this one to second one, and so on and so on. So XOR key will not damage service areas and we will not have any shifts. Everything will be good and beautiful. So this is quite an important step. We shouldn't forget about this. It's a quite typical, popular mistake of engineers. So pay attention that you clicked on that button. If you'll use automatic XOR key search from database, you shouldn't worry about this. It will be checked by default. But if you do manual extraction, if you apply some some external key, not from database, or you selected it manually, then you should care about this adjustment. You should click on the button. Okay, now I just wanted to show you how to extract XOR key. So we have such a solution, and the XOR key is necessary to extract. So if you remember, I need to select the previous element from which I want to extract it and run XOR analyzer. Start auto detection. And now we have some candidates for XOR key. We will not use it. We will try to extract it manually. So that's why I switched to the source. And now I will make the scale a little bit smaller. And let's have a look. So for example, if we watch into some standard keys, standard blocks, they will look like this. So you see just a noise. This is normal looking data when we have XOR, in some particular case. And the XOR key will have some patterns, and you can see that the, for example, difference between this pattern and this pattern. Here we have some like contaminations of XOR key. So not only zeros was written in this block, but also some data, and it looks like it's fat tables written here. If we'll select this key, so here is the result much clearer. And the next step would be to check how many patterns can we recognize, how many similar patterns. And you can see, for example, like this line starts from the top, and then after the center, we have one more line is going here. Then again, one line here, one line here. So this particular example shows that we have, oh, here's a very good place. One line, second line. So we have two patterns in one, two keys in one block. Once we found that, then what do? We can divide this block size for analysis by 2, like this. And yeah, now it's red because probably some of those test points were on, on this area which we just removed from analysis. And but I'll click Run Auto Detection, and it will select new test indexes from this smaller block and read blocks again. Okay. So now we should have bigger number, and we do have bigger number of that same blocks. And then all we need to do, I will uncheck firstly all the blocks. Now all we need to do, we need to select several ones with the most same patterns. So you see, if I switch these two blocks, in this area, we have some changes in here. Have a look. Oops, no. Why we don't see it? Okay, maybe now. Yes, you can see that. First page is changed. Here we have some changes in this place. If we switch these two blocks, now you see this area in the end. So it's not a good idea to take, if you can't have a choice, you can take these two blocks for the XOR key. But if you have a choice, bigger one, so you can try to find the keys where you don't see any changes. For example, these three, you see, they look quite similar. So I will check 3 of them, and then click to extract selected blocks. So 3 blocks are extracted, they are here. And what's next? The next step would be to check if we don't have any uncorrectable bit errors here. So I will select ECC and click 3 times on this copy button. Oops. Yeah, I did it 4 times. And we can see that all errors are correctable. All right, that's good. Then we need to join all these 3 results into one with a bit-by-bit comparison. So BitVerify will take each bit from each result, compare, and take the most, let's say, popular one. So after this, we have a look. We have our key, probably quite good one without any data contaminations, but with the service area and ECC here. So to remove them, and if we will apply this service area and ECC to our data, maybe it's not going to be a big problem for ECC because we could fix it on this step already. But the data area will be changed, and then we will not be able to work on Markell's table here because full data area will be different. So that's why we will use data area element like this. And then what? And then XOR. Let me just move it a little bit like this. XOR, and data should be supplied to first input, and through the second input I will connect my result from here. And in this, by the way, in data area, if we will set up page size 8192, we'll see the same key like before, but already without ECC areas. We can see that there is a border here, you see? Can you spot this? Yeah, you should see that. So in this place we had a data area, now we don't have it. And that key is supplied to the XOR. And if you remember, if we will just use it without any adjustment, then first data area will be XORed, second data area and all another ones will not be XORed because key is not adjusted. Key now looks like this. As you could see that data area, page looks like this. So it should be adjusted to precisely this one, this structure. And to do this, all I need to do, I will click on this lamp button like this. And I can leave auto settings. With auto settings, the data area will be adjusted. And that's it, I guess. Here now data should be XORed here. And I think that it should be done. If I run ECC correction, yeah, now it will work much slower because it needs to make all that bit verify comparison. Extraction, XOR. Much more things to do. Okay, markers table was done before. It's prepared already. And file system is here. So we can see that we didn't use at all XOR key from database. We took it from the dump, and dump can descramble itself. The next one would be this one. So two physical images, same approach, XOR analyzer. and probably XOR key. Yes, and we can see that these these several blocks, they have same kind of data, but they don't look like some patterns. They look like a noise. And in this case, how can we guess? Like, how can we get some information that there is a chance that this is XOR key? We can have a look on signature here, because if you remember, signature, it's the first several bytes of the block, and those first several bytes will be the same like XOR key signatures. Why did I have it here? We can see that zeros, they do not change XOR key, right? So first several bytes in that zero blocks will be the same like a XOR key, first several bytes. And in our database, we have such a thing like a XOR key signature. It's like a name of XOR key, or starting, first start of XOR keys. And those signatures you can see here in this list. And for example, if you don't have any key in this area, I mean any compatible key, you can just have a look on signatures, typical signatures for this particular controller. For example, we have a SAM controller. So we can set here in vendor field a SAM, and then we may see different signatures of XOR keys which are typical for these controllers. You can see that they are more or less similar. I mean, there are not each key has a different signature. They start from same bytes. And we can see that, for example, there is a signature like 4C91-A, and such same signature we have here. And if we would find something like this one, and we don't have these blocks, for example, then we can just go through the signatures, check such signatures in this list, and maybe somewhere later we will find it, because you know, this algorithm works pretty fine, but sometimes it doesn't for some particular cases, and that in those cases blocks with XOR key will not be on the top. They could be somewhere else. So you can check what signatures you have here, and then try to search for that signatures in this this list, and check the blocks more carefully. Maybe those blocks will have XOR key. In our case, what do we have? We have that we have noisy looking something, and this something has signature which is typical for SM controllers. So we can say that there is quite a big chance that this is actually XOR key. Yes? Okay. Now now we need to understand how many keys do we have in this one block. And with the noisy looking keys, it's not that easy. It's not that obvious like before, but approach is still the same. We just need to find some patterns and count them. Those patterns are not similar like to previous ones where we could find it very easy because it's a noise. However, even in this noise, we can spot some similar areas. And here, for example, I can see, such a group of ones, you see here, and one more in this area. So 1 and 2. we will keep scrolling one more time. You see this group of ones here and here, or you can just make, I don't know, in this case. Actually, I wanted to tell you, to show you. For example, you just have a look on lights. Shouldn't click. You need to find some recognizable thing which you can clearly see in first area, and then just go to the end and look for the same thing. For example, you see this whitish area, and then gray area. And if you will go to the bottom, you will see again this whitish area. I hope you can spot this on your screens. And then again, and these two areas, like this one and this one. So after some time, you get used, and you will see patterns even in the noise. And once we found that, here is a good example. We see 1 and 2. So 2 patterns in the noise. And that means that we have 2 keys in one block. And then what? Then we divide test block size for testing by 2. From this one, like this, with this button, and run auto detection again. Okay, let's have a look. And you see, before we had just 3 keys, maybe 3 blocks with a key. Now we have much more, well, 2 times more. And so what now? Now I will try to select the ones where I don't have any change, like these 2. You see they're similar. For example, this one is changed. No. Here, 1, 2, and 3. You see, because for example, if I will take this 2, there is some change in here. So I don't think that it's good, that it would be a good choice to take those 2. However, they may work because of bit verifier. Still, it's better to take as same as possible. So 1, 2, and 3. 3 keys. And then just extract selected blocks. Let's place it somewhere here. Then ECC 1, 2, 3. Yes, we can create, the question is if can we create new XOR key with existing one? We will do this actually with the next case. So you'll see that how we can do that. Okay, so ECC, then bit verify. Where is bit verify? And connect it like this. Then data area. To XOR elements. Yeah, and of course you don't need to extract now XOR from the second image because you can use just this one that we extracted right before. So it's connected like this, and then the last step is this one. Almost last. We need to click and this here. Okay. Create logical image. Run ECC. Or maybe it's not necessary here to run it. No. We'll use okay. Now let's try to open it. And here it is. So it's good. It's working. And one more key is extracted. Any other questions about this case in particular? Okay, and the next thing that I wanted to show you, to tell you, is that our database, it's a quite big one. And we try to add as many XOR keys as possible. However, sometimes you can see that it doesn't have necessary XOR key. But in most of cases, XOR key could be like partly compatible. It could have a different size in our database from your device. And it may be necessary to adjust existing XOR key from database to your specific case. It works like this. For example, you ran XOR key analysis, XOR key search, and then you got such a result. You got some keys here. By the way, let me tell you how do we create this this list of keys. So there is a filter here, and if there are no any values in these fields, then you will see all like all possible keys from our database, all keys here. And then when we run search, we'll have here automatically XOR key size for data area only, and if full, so it's going to be 8192, or for full page, if a full page is XORed. So we'll have here two sizes. Come on. Like this. So data area size only and full page size. Also, we can set up here, or you can set up here manually, page count, so like XOR key size in pages, vendors, for example, PS. Now you have only PS controllers, then SM controller, and so on. But what do we use when we create this key, this list of keys automatically? We take signatures from each and every block here after analysis. For example, if you have 1000 blocks in analysis here. So we take all those 1000 signatures and insert in this signature field. So then if there will be blocks with this signature, if there will be blocks with XOR key in this list, and there is quite a big chance that they will, then those signatures, real ones, like real XOR key signatures, will come here. There will be some garbage, like for example this one. If we insert it, like 5C1F, 5C1F4E. We don't have anything here, right? If we insert only this signature, but if we will sort all of them with all these, let's say, garbage signatures, we'll get also this one, 4C91 to A. 4C91 to A. And these blocks will bring these keys, which are probably will be good for your particular device. So after you get this list, which is filtered out by the rules that I just told you, you may see such a situation. You ran validating of the XOR key, and one may show you quite good result, like almost 100%, but it's not bolded. It's not bolded because page size, size of the key in pages is different. We have a case with 256 pages, but this key size is 258 pages. So it's a little bit bigger, and you cannot apply it because you know, one block will be XORed, and next ones will be XOR key will be shifted for next blocks, so it will be all corrupted. It's not going to work. In this case, and this is actually quite typical case, because one more time, as I told you, we try to add as many as possible keys, and nowadays it's not a big chance that you will have a key which is not in our database. There is a bigger chance that you will have a device with a key which is slightly different from ours, from our database. And then you will need just to adjust it a little bit, the size of the key. And one of the typical cases when block size of your device is smaller and our key is a little bit bigger. And then it would be good somehow to take only 256 pages from this key and try to apply it for your device. So you see the idea. We have a device with 256 pages in one block. We have a key which is compatible, but it's a little bit bigger, and that's why we cannot use it. 2 pages are unnecessary in this key. So what we can do then? We can just extract 256 pages out of that 258 pages with the extract area element. It's quite problematic topic for you guys because usually you complain that you can't use it. However, there is an article about this, about these topics, about these tools, and I think it's I don't know how to do this better because for me it's all looks very obvious. Let's talk now also about this. How do we use extract area? When we clicked on extract area element, we have to define period. So on which area this extraction will be repeated. If we want to extract some just one block, for example, from full dump, then period will be one dump. If we want to extract several pages from each block, then period will be one block, and here we will set up parameters of those pages. If we want to extract, I don't know, for example, several bytes from each page, then period here will be one page, and here we'll have parameters of extracted bytes, the bytes which we want to extract, start address and length. So our task now to extract 256 pages from 258 pages. XOR key size 258 pages with the page size 8192 bytes, and we want to extract 256 pages. So period gonna be 258 pages, so like full dump, right? Because we have now we do extract data from XOR key. So XOR key size is 258 pages, and we want to extract this one, this area only once from this like full dump. So that's why the period will be full size of XOR key 258 pages. Then area where we will start extraction, it's a 0 because we want to extract it from 0. And then the length is 256 pages because we want to extract this number of the pages. So period is 258, and here we set addresses in bytes. Here addresses in bytes. 258 multiplied by 8192 we'll get this number. 256 multiplied by 8192 we'll get this number. Yeah, Luca, I'll show you how do we import keys to offsets. You can, yeah, you will see that. Actually, there are different ways. The way I did it, I just opened XOR key as a binary file and then extracted this area from that binary file. So that's why we can extract this necessary amount of pages from the full key. Now let's see this on the example. So there is a next case. And here, when I run XOR analyzer, not here, let me run it on ECC, XOR analyzer. Okay, so there is a quite big list of blocks where I can test keys, and I can just run it on the first one. And as you can see, this one seems to be very good, but page size is not. Page size is bigger here, and we need somehow to bypass it. Of course, we can try to extract XOR key from this dump, like I just showed you before. But if there is a way to try to adjust our key, I think it's better because, you know, for example, this dump, have a look how much contaminated it, and by bit errors. And if even one bit error will go from this key to from this block to the XOR key, then that bit error will damage full your dump. So it's better to take keys which we checked that should be good already. Most probably they should be good without any bit errors. And yeah, adjust the ones like from Echelon database. And now I will show you how to adjust these ones. Okay, so I should remember name of this key and just import it into the workspace. Let me just quickly do this. I think the better way to proceed like this. So I will click to apply key just in order to copy the name of the key like this. So I will copy name of this key and now open image, drive C, program files. Now I'm going to the place where we keep XOR keys. It's Silicon Motion. And here I insert the name of the key and extract it. So I don't need anymore this element. And the key is here. And I'd like to remind you that this key has 258 pages. And our device has 256 pages. So to extract these 256 pages, I have this image, and all I need to do, I need to click on this extract area button. And here in these parameters, I need to adjust it. How will I do that? Let's see. Period is 258 pages. Let me share calculator. So 258 pages, and I multiplied by 8192 because this key is for data area only, and the page size is 8192. So that's the number, and actually it's I have this number already in a period. You can see that here, the same number. So I don't change this one. Start address gonna be 0 and length gonna be 256, right? Multiply by 8192. So that's the number I want to take, I want to extract. And I'll set up it here. And there we go. So now this offset has 258 pages from, 256 pages from the original key. Let me just check it. Yeah, it's noisy looking. Okay, so then what? Then I connect it like this, like that, and adjust key to data area. And now data area is unscrambled, descrambled. So I can see patterns here, and it's quite okay, quite good. But it's not all. This case has also this problem, let's say. Service area is XORed. We don't see any LBN here, anything, any header, any LBN. We don't see here anything. And we need to create XOR for this part too. How will we do that? There are different types of XOR key for service area, and all information about all the types and how do we extract XOR key for the types, you can read by this link. It's a link to the PDF presentation from our tip-off week from previous year. So there are descriptions of types of XOR keys for different types of different XOR keys for service areas. And one of the easiest one and the best one for us, for data recovery engineers, is the key which just repeats first service area. So in case if we have 6 bytes service area, like in our example, XOR key may be just the first 6 bytes out of the first one, the first portion of the key. So from here. And if we will take these 6 bytes and apply it to the service area, it should be fine. And this moment, I don't know this in advance. Either it's this way, this type of XOR key, or another one. But it's quite easy to try, and I will do this. I can take 6 bytes from the XOR key, try to apply it to the service area, and see if it will work or if it will not work. This is what we usually do when we do research, guessing how it may be, and try some variants. And again, for this operation, we will use offsets. We will use extraction. But this time, what do we want? We want to extract 6 bytes from 8192 bytes, right? So then, period gonna be why 8192? It's a page size of the block. So period gonna be 8192, start address 0, because I want to take this starting of the key, and the length is 6 bytes. Very simple. Okay, let's do that. And I can do this from the same offset element, like from the same XOR key from here. Extract area, period 8192, start address 0, length 6 bytes. So one more offset is here, and this one As you can see, it's just the first 6 bytes. Okay, then what next? I have 6 bytes, first 6 bytes from the XOR key, and I want to apply it to the service area only. And to do this, I will add one more XOR element connected like this. And this time, instead of adjusting so this is our XOR key now, and we need to apply it on this service area only. And this time, instead of adjusting with the outer settings, with default settings to data area only, I will switch it to service area only. So the key will be converted into such thing, into such view, and then this XOR key will be applied precisely to the service area only. So I'll click on this adjust key and check outer and then service area only. And let's have a look now. And here it is. The service area now is unxored. So on the first step, we descramble data area, now service area. And then we can just proceed with the regular things like pair, markers table, and so on. This case, unfortunately, doesn't have file system because some of blocks are still corrupted or they are lost. But if we will run file carving, we'll see that files will be there. Okay, I guess it's enough. So 15 pictures are here. Yeah. So it works. It works, and this is how you can adjust the key from the service area. Sorry, from the database, and actually to create the key for the service area. With the offsets and adjust key button. Let me check if yeah, that's the last page. Then I believe that's all. This webinar, after some time, will be uploaded to the YouTube, so you will be able to see it again if you want. Put your fingers up and all that stuff. Blah, blah, blah. And yeah, thank you Thank you so much for attending. I hope it was useful. It will be useful.